Derivatives of trigonometric functions. So here are 4 rules for derivatives. The first one says the derivative of tangent of x with respect to x is equal to secant squared x. So again, we'll go through the proofs for some of these. But for now, you're going to want to just memorize these rules. The next one, the derivative of cotangent of x with respect to x is negative cosecant squared x. The next one here is the derivative of secant with respect to x is secant x tangent x. The next one is the derivative of cosecant of x with respect to x is negative cosecant x cotangent x. So if it is a cofunction, cotangent or cosecant, notice that it's negative. If it's not a cofunction, if it's tangent or secant, it's positive. So let's go through the proof of one of these. Okay, let's try to prove that the derivative of tangent x is equal to secant squared x. Okay? And we're going to do this by allowing tangent x to equal secant or sine x over cosine x, and we're going to apply the quotient rule. So remember the quotient rule, the derivative of f of x divided by g of x with respect to x is equal to g of x times f prime of x minus f of x times g prime of x, and all of that is over g of x squared. Okay, so let's try this. So we want to take the derivative with respect to x of sine of x over cosine x, where f of x is equal to sine x and g of x is equal to cosine x. So if we apply it to this rule, g of x is cosine x. The derivative of f of x would be cosine x, because the derivative of sine of x is cosine x, minus f of x, which is sine of x, and the derivative of cosine, which would be negative sine x. And this is going to be g of x squared, which, let's replace g of x with cosine x. Okay, so now we have this. So let's keep going here. The derivative with respect to x of, remember that this is just tangent of x. This would become cosine squared of x, and this would become positive sine squared of x, all over, this would become cosine squared x. And then through identities, we know that this is the Pythagorean identity, so this would be 1 over cosine squared of x, and 1 over cosine squared of x is secant squared of x, which completes our proof. Alright, so let's try some of these problems. Let's go down to this problem here. And let's find the derivative of secant of x. So the derivative of secant x, according to the rules that you might not have memorized yet, but if you scroll back up, this is going to be secant x tangent of x. Okay? Now, let's say that we want to find the second derivative. So now I want to take the derivative of this function. Okay? So now I'm going to have to use the product rule. So the product rule, you take the first function, which is secant x, times the derivative of the second function, which is secant squared of x, plus, so it's the first times the derivative of the second, plus the second function times the derivative of the first function. So it's going to look like this. And then we can simplify this. We can make this secant cubed of x plus secant x tangent squared x. Then we can factor out secant x, and then I have secant squared x plus tangent squared x. And then we can simplify this a little bit more using one of the Pythagorean identities. So we should be familiar with this Pythagorean identity. Let's see if we can turn one of these into tangent squared of x. I can do that by dividing this one by cosine squared of x. So then this would be tangent squared of x plus 1 equals secant squared of x. Then I could subtract 1 from both sides, and I get secant squared x minus 1. Now that equals tangent of x. So now I've got secant x equals secant squared of x plus, I'm going to replace tangent squared of x with the secant squared x minus 1, and then this would be secant x, this would be 2 secant squared x minus 1, and then this would be the double derivative of our original function. So taking the second derivative, I think you can see is not too bad. You're just taking the derivative twice. Alright, for example, this one here, if I take the first derivative, it's going to be 2x minus 9x to the fourth. And then if I want to take the second derivative, you just take the derivative of the first derivative. So the derivative of 2x would be 2. The derivative of negative 9x to the negative fourth would be positive 36x to the negative fifth.